Okay, we're given a polynomial equation x to the fourth minus 4x cubed plus 7x squared minus 16x plus 12 equals 0. We're asked to use part A, the rational zero theorem, part B, Descartes' rule of signs, part C, the theorem on bounds, and use those to find all the complex zeros of this polynomial equation. And we are starting with part A, the rational zero theorem. We're going to make a list of rational zeros, P over Q. They're going to be equal to, I put my plus or minus out in the front, curly set bracket. Now I'm going to put all the numerators on the top and the denominators on the bottom. Now the numerators are going to be factors of the constant. And the constant in this polynomial equation is the number 12. So we're going to have 1, that's a factor of 12, and then 2 and 3 is a factor, and 4 and 6 and 12, and that is it. No more factors for that constant term, 12. On the bottom, we're going to list all the factors of the lead coefficient. That's the number multiplying x to the fourth. The invisible one, it only has the factor plus or minus 1. We took care of the plus or minus out here in the front. Don't forget that. Okay, now we're going to break these apart all over that denominator 1 and get a better list, a refined list. P over Q is equal to plus or minus, curly set bracket, 1, 2, 3, 4, 6, and 12. It would have been more interesting if we had more than one choice for the denominator on the bottom, but this one was kind of easy in that regard. So there, I'm going to put a box around that because that is our first conclusion. This, of course, is our list of possible rational roots. Remember, real numbers are composed of two different categories, rational numbers and irrational numbers. So this is just a segment of the real numbers that we are looking at right now. Now we're ready to go to part B, where we're going to use Descartes' rule of signs. And first we note that the degree of this polynomial is equal to the highest power on the variable. It's 4. So that implies that we are going to have 4 complex roots. And of course, zeros, roots mean the same thing. And that, of course, I'm going to put a box around that. That's important. And, of course, that includes multiplicity. And now we have our f of x that was given to us, our polynomial. It's equal to x to the fourth minus 4x to the third plus 7x squared minus 16x plus 12. We're going to watch the sign variations in f of x. It started positive, then it became negative. There's our first variation. Then that negative turned to a positive. Here's our second variation. Then that positive turned into a negative. That's our third variation. Then that negative changed to a positive, and that is our fourth variation. So that implies there are 4 variations of what? Of f of x. And that implies the quantity of positive real zeros could be the number 4, the number of variations minus 0, which would be 4. Or another possibility would be the number 4 minus 2. That would give us 2. And the other possibility, 4 minus 4. See how we're subtracting? 0, 2, 4, 6, 8. That would give us 0. And the next would be 4 minus 6, but that would give us negative 2. We don't want negative results. So this is a result for what? This is a result for possible quantity of positive real roots. So it's going to be either 4 of them, 4 positive real roots, or 2 of them, or none of them. Next, we're going to evaluate the sign variations in f of negative x. Okay, we're going to evaluate f of negative x, and a quick way to see that, oops, my kitty's meowing. A quick way to see that is simply to take all the odd powers of the variable and change the sign in front of them. The even powers don't change. Because you raise a negative base to an even power, it's going to remain unchanged. Okay, so we have x to the fourth, then the negative 4x cubed that comes next becomes a positive 4x cubed, and then the positive 7x squared, that's an even power, so it's still positive x squared, and then the minus x 16x becomes a positive 16x, and of course the constant remains unchanged, 12. Okay, so now we're going to count the number of variations. Everything's positive. Nothing changes signs here. So that means that there are 0 variations for f of negative x. And that implies that there are no negative real roots. There's nowhere to go with this one. And that kind of makes things easier for us. That's cool. I'm going to go ahead and put a box around this. No. Well, I'll put it like this. Okay, so now we're going to take that result and we're going to build our table. And our table will be continued on the next video.